So what I'd like you guys to do here is, can you guys start filling through this table for me real quick? While you guys do that, I am going to pass back your quizzes and homework. Okay, so as we put these in, did you guys get, 20 here? And then 200? And then 2,000? And then undefined? Does this feel about right? Okay. And really what's happening is, as we did this, we ended up with 2 over 0.001. Is everybody good? And so what's happening, the top is staying 2, the bottom is approaching 0. Is everybody with me? Okay, so what's happening to my y values as I have it, they're going up, and not only are they going up, they're going up wicked fast. Is everybody good? So the limit doesn't exist because it's going to infinity. Is everybody with me so far? Wait, were all of these negative? Yeah, negative. So what was happening, the top was staying at 2, so approaching 2 if you wanted to. The bottom is approaching 0 from the negative side of 0. So we had a positive over a negative. So that bottom was, so I like to think of it as that if I'm looking at this particular one, my limit is 2 over a negative 0, which technically is not true. Right? Because you can't have negative 0, but in terms of my thinking it's 2 over a really, really tiny negative number. So really close to 0, but negative. Is everybody good so far? And when that happens, so we got 2 things going on here. We have a non-zero constant over 0, and then we have to think through, is my answer positive or negative? Those are the 2 components that we want to be thinking through here. So, new rule is, and likewise, if I did it this way, we had positive 2 over positive 0.001, right? Because we were approaching from that right-hand side. Now I have 2 over a positive 0. Is almost like a way of thinking that through. Okay? And so now we had, as we were getting closer, we were actually going towards positive infinity. Okay, so here's the deal. We are now going to start talking through what happens when we approach things that we have a non-zero number on the top, and a 0 on the bottom. Okay? If we end up here, we have either a positive or a negative infinity for our limit. The limit does not exist, but we can describe it as going towards infinity or negative infinity. And how do you decide if it's infinity or negative infinity? That's where I think having kind of this kind of, even though that 0 is technically isn't positive, it is because we're approaching from the positive side. Is everybody good? Okay, so vertical asymptotes are always going to happen at whenever you have a number, a non-zero number over 0. 0 over 0 is a whole. Anything else over 0 is an asymptote. If it's a vertical asymptote, that means your limit is going to be pointing towards infinity or negative infinity. Everybody okay? All right. So, determine if these limits have any asymptotes. So, what would you do to the first one? Factor. All right, if I ask you to show analytic support of vertical asymptotes, what I would expect is, where would you find it? You guys, where is the vertical asymptote here? X equals -4. And then you want it to show me it's an asymptote. Analytically, you're going to find the limit as we approach it from the left and from the right. You guys, if I plug in, if I approach -4 from the left, I get -8 on top, -0 on the bottom. Are we all comfortable with this? I know that -0 feels icky, but like in terms of our thought process, are we good? That the bottom is getting closer to 0 on the negative side. So overall, is my value going to be very big or very small?
Very big.
Very, very big. Positive, right? Because the top would be negative. It'd be like -8 over -0.000000002, which would be a very large positive number because I'd have negative over negative and then a really, really big number. Do you guys see kind of how we're thinking that through? Okay, so as I'm approaching, oh boy, you guys. Never mind, I'm gonna shut up. Yeah, it's all good. All right, the other way around, if I'm approaching -4 from the right, what's happening? Or from the left, I'll have -8 on top again. And on the bottom, I'll have 0, but now I'm doing like negative. Yeah, I think I have this backwards, don't I? Yeah. Because -4 from the right is like -3.9. -3.99. Right? And so the bottom would be negative. And if I approach from the left, the bottom. Or the bottom would be positive, the bottom would be negative. Everybody good? All right. What about tangent x? Where are the vertical asymptotes of tangent x? It would be helpful since we're defining vertical asymptotes as a denominator equals 0 and the numerator does not, it would be helpful to write tangent as a fraction. Sine x over cosine x. So where will this equal 0, or where will this be undefined vertical asymptotes is where does cosine x equal 0? pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2. I'm going to call that k pi over 2. We're going to do this for one of them, and that'll be sufficient, okay? So we're going to say, well, what is the limit as x approaches pi over 2 from the left? Now, this might start to feel a little bit uncomfortable. Because approaching pi over 2 from the left is approaching it from the first quadrant, which feels really icky because the first quadrant is on the right of pi over 2. But when we're doing this, if pi over 2 is right here, like what can we say about this angle? This angle is smaller than pi over 2. Do you guys see what I'm saying here? Okay, so like if you were to think of when we graph trig functions, like from here to here is the first quadrant, second quadrant, third quadrant, and it doesn't, so even though, can I shut up now? Great. So what's happening at tangent as we're approaching it from the first quadrant? Well, we can think of it as sine over cosine still, right? What's happening to sine as we approach from the first quadrant? It's approaching 1. And cosine is approaching 0. But are the values of cosine positive or negative in the first quadrant? Positive. So it's approaching 0 from the positive side. Everybody good? So I would call that positive infinity. But as I approach pi over 2 from the right, okay? So I'm approaching pi over 2 from the right. I'm in the second quadrant. What's happening? What can we say about the values of sine in that second quadrant?
Still approaching 1.
What about cosine? Approaching 0, but from the negative side. All right, and I suppose for both of these, I didn't really say, the whole idea is determine the vertical asymptotes. So our vertical asymptote is x equals pi over 2. For this one, our vertical asymptote was x equals negative 4. And our analytical evidence was that these limits were going towards infinity.
For the tangent one, if you just say pi over 2, like that's the one we use.
Yeah, so technically it's k pi over 2 because it's going to keep being the same idea. I think that would be an example of something I might put in a, what I might put in the notes versus what I might put on a test are not the same. I really do try to put the hardest questions in the notes rather than on the tests. I try. Can't say I'm always successful. There's going to be at least one on your second test that you guys are like, I hate you. Just one, though. The rest should all feel fair. Maybe. All right. Because this one we're not checking for estimates. We're just saying, what is the limit? So as x is approaching 0 for this particular problem, what are we getting? 1 plus infinity? Definitely positive infinity? Yeah. Yeah. In this case, x squared, whether I'm approaching from the right or the left, once I square it, it becomes positive. 1 over 0 is... So, you guys, what do we know about 1 plus infinity? It's infinity and beyond, for sure. Yeah. So this one would be 0 plus 1 over 0 negative close to 0. which is
Negative.
negative infinity. Are we good? Ooh. Thoughts on this one? What do we know about the graph of the natural log of x? All right. It is assumed that you guys understand what the natural log functions look like. Okay? Are we good? Could you graph this in your calculator if we needed to? Okay? So what's the limit as x is going to 0 from the right? Negative infinity. Would I give this to you as x approaches 0 from the left? No. In fact, anything, you guys are going to see a lot of things where you have to find where I start limiting domains whenever we're using natural logs, because like it only applies, the domain of the natural log function is that has got to be greater than, strictly greater than 0. Okay. Oh my goodness gracious. What do you guys think about this one? Let's think this through for a sec. I'm approaching 1/2 from the left. And if you wanted to, you guys, we could call that 1/2 times 1 over cosine of pi over 2. Again, from the left, cosine of pi over 2 was 0, right? But from the left is the first quadrant. Cosine is positive in the first quadrant. So I have 1/2 times positive infinity is, like infinity. Because half of infinity is infinity and beyond as well. It's like half of a lot is still a lot. Sort of. Ooh, you guys, this one's really pretty. Is this an asymptote? Does this go towards infinity? No, because I end up with 0 over 0. Yes? Okay. So here's what we're going to do. We're going to take the limit as x approaches 0 from the left of the absolute value of x over 5x plus 8x over 5x. Let's start with the easy one, you guys. I can cancel those x's, so then what's my limit? For the 8x over 5x, if I cancel those x's out. 8/5. Technically, it's negative 8 over negative 5. Because we're approaching 0 from the left. Kind of. I guess not, because that x is canceled. But on the next one, it kind of matters. Okay. So, whereas on the... whereas over here, it is still kind of negative 8 over negative 5, because you're not canceling the x. It's more like the x's are... It's fine. What can I say about the value of the numerator here as I am approaching 0 from the left? It would be positive. What about the denominator? It would be negative. Everybody good? So the overall value of this fraction will be negative 1/5. Seven fifths. And if I was approaching 0 from the right, it would be positive 1/5, positive 8/5, because both the numerator and the denominator would be positive of that first fraction. Because that, so,
Because the top.
so let's pick a value close to 0 from the left. Okay, so that value close to 0, let's do 0.01, negative 0.01. Okay, so I'd have the absolute value of negative 0.01. Are we good? Are we seeing this now? It's a tough, these are weird ones. They're ones that students typically struggle with, for sure. Okay? All right. What can we say about the top? Square root of 1 plus 8 minus 2 is 1 over 0, but what kind of 0? A positive, a very close to 0 positive, yeah? So this one goes towards positive infinity. So isn't this fun? All right. So those are what I would call infinite limits that approach infinity. Next, we're going to talk about limits at infinity. So we're going to talk, when we talk about end behavior, we're talking about what's happening at the right and left-hand side of our graph. So we are end behavior is always talking about x approaching both positive and negative infinity. Okay? And sometimes our end behavior is stuff that's like, as x is going to positive infinity, y is going to positive infinity, right? So like for any of those polynomial functions, end behavior just looks like that, right? But sometimes we have end behavior asymptotes, like horizontal asymptotes, etc. Okay, we're only in this course focusing on horizontal asymptotes in terms of end behavior. All right? So those are the only times I will ask you to find an asymptote. Let me put it that way. Okay? All right. So let's consider the function 2x squared over x squared plus 4. You guys, in your brains, what does that limit equal? Do we have an idea? Sorry, thanks for playing. So let's play this out real quick. If I plug in 10, what do I have on top? 200. What do I have on the bottom? 104. All right. If I plug in 100, so like this is my exponentially growing x getting towards infinity, yeah? Going up really big. All right. You guys, 200 divided by 104 is going to be like 1.96 maybe? 1.92, thank you. All right, and if I do this one, I would have 20,000 over 10,004, yeah? Are we comfortable with what's going on here? What's happening? You guys, this limit is 2. Is everybody okay? And because this is an x squared, do you guys mind if I skip this part because the squared becomes positive? Is this okay? All right. But are we comfortable with what's going on here? So in this case, we could say we have a horizontal asymptote. Because as x is going out forever, the y's are all getting really, really close to a horizontal line of y equals 2. Because the limit as x goes to infinity is an actual number, we have a horizontal asymptote there. Is everybody are we cool with what I'm saying? And we can see it graphically. Yep, thank you. And if I keep going, you guys with me, you can start to see it graphically. Everybody good? All right. So again, horizontal asymptotes occur that if I'm approaching infinity or if I'm approaching negative infinity, I have the limit exists. Then it's a horizontal asymptote. Everybody okay? All right. Now, you guys, let's think about the graph y equals 2 to the x. What is the limit of y equals 2 to the x? What is the limit as x approaches negative infinity? 0. What about as x approaches positive infinity? Infinity. So, exponential functions have horizontal asymptotes, but they're only a one-sided asymptote. Okay, but we can still say there's a horizontal asymptote to y equals 2 to the x. Everybody good? What if we made that instead of 2 to the x, I made it 1/2 to the x? Now as x approaches negative infinity, y approaches infinity. As x approaches positive infinity, y. So still, both of them have a horizontal asymptote, just one-sided. Everybody okay? All right, so if I ask you to find horizontal asymptotes, you still have to be able to take a limit as x approaches infinity. Is everybody with me? Okay, so here's what we're going to do, because we're not allowed to use L'Hopital, remember? Which is super annoying, I get it. So if I'm doing this problem, and what I need to show is the limit as x approaches infinity of f of x. How do I take the limit? Because if I take that limit right now, I'm going to end up with infinity on top and infinity on the bottom. And while I'm good with saying a number over infinity is 0, I'm not comfortable with saying infinity over infinity is 0. Because not all infinities are created equal. Is everybody with me so far? Okay. So how do I show this?
I do it based on degree of the numerator versus the denominator. So whichever, like the denominator has the higher.
If we're going to say that, we need to have like a little bit to back up like why.
Because you have an infinity squared on the bottom.
You have more infinity on the, there's one way of thinking about it. I'm going to show you a slightly different way, okay? Here's what we're going to do for problems like this. We're going to pick the highest degree term we got, which in this case is x squared. And we're going to multiply the top and the bottom by 1 over that value. And again, as long as I do it to the top and the bottom, no problem. So I'm going to rewrite f of x as, well, let's see, x over x squared is 1 over x. 3 over x squared is 3 over x squared. I have 1 minus 4 over x minus 5 over x squared. Again, so essentially what we're doing is turning each term into something over that infinity. Okay? So if I do 1 over x, that's 1 over infinity, I get 0. 3 over x squared is 3 over infinity is still 0. The 1 stays a 1. 4 over x becomes 0. 5 over x squared becomes 0. So now we've done an algebraic manipulation that doesn't get me in the way of that not being able to use L'Hopital. And still lets us use those basic limit rules. And I get 0. And then I'm going to take the limit as x approaches negative infinity of f of x, because it is possible. it is possible that you have two different, in fact, we will have some problems like this, probably not until Wednesday. Okay, we'll have one more hard type of question on Wednesday, and then we'll be done with all the hard stuff, and you guys can just kind of work through some of the stuff. Test Thursday, Friday. Okay. So now we can say we have a horizontal asymptote at y equals 0. So what I will expect is show the analytical evidence of a horizontal asymptote, my expectations would be to see the limit as x goes to positive infinity as x goes to negative infinity. So let's look at this one. If I follow that exact same approach here, in this case I end up with 5 over infinity, which is 0. This one I get 5 over negative infinity, which is still 0. So I have a horizontal asymptote at y equals 0. We're going to skip C for now. For this one, I'm going to multiply by 1 over x cubed. I'm picking the highest degree term. So 4x cubed times 1 over x cubed will just be the 4. Then we'll have minus 4 over x plus 5 over x squared minus 2 over x cubed. Oh. I'll give you guys a second to process that. Are we feeling comfortable with just where those numbers came from? Okay. So we've rewritten g of x. So now if I ask you guys, what is the limit as x approaches infinity of g of x? And at 4 minus 0 plus 0 minus 0 over 3 plus 0 is 4/3. Everybody good? And if I ask you what is the limit as x approaches negative infinity of g of x, we would get, for the same reasons, 4/3. So I have horizontal asymptote at y equals 4/3. Everybody good? Thoughts? What, the first one is 0? You guys, when do exponentials get really tiny in value? When the exponent's negative. Like, think of it, 2 to the negative 3, 2 to the negative 4. All right, so if I'm saying e to the negative infinity power, that would be a really tiny exponent. And what about And then this one, negative infinity would be e to the positive infinity. Go up really fast. You guys, if you wanted to graph this and sketch the graph for me, that would be sufficient. Everybody okay? It's always okay to sketch a graph. Ooh.
What would we say for that one though? Because
I would say you would have a horizontal asymptote at y equals 0 when x is approaching positive, or not x. In that case, I would specify it's only there when t is approaching the positive infinity. Because this next one's really good. What's the problem with this one?
Sine of x can't be more than 1.
Sine of x, it can't be bigger than 1, can't be smaller than -1. It's always in between -1 and 1, right? So are you guys with me that sine of x is going to be, we could say this. For the sine of x is somewhere. I'm not going to use y. Y is probably, let's just use, I'm going to use c, okay, for some value. Over infinity. Are we always going to have a number over infinity here?
Yeah.
What do we know about a number over infinity? We don't know what that number is, but we know that the bottom's rising a whole lot faster than the top. Okay? And so when the bottom's really big and the top's small, that's really close to 0. You guys don't want this last one yet. I know you don't. Does anybody want to guess what this limit is? Because I'm actually super curious. I'm sorry. What is the limit as x approaches infinity? The analytic evidence is a monster on this problem. I'm going to wait till Wednesday to show it to you guys. And then I'll have extra practice of that, just that skill, because it's the one that is a doozy. Does anybody want to take a guess?
2. Yeah, sure. 2.
Why 2?
Square root of 4x squared.
The square root of 4x squared is... What about if x is approaching negative infinity?
I would say it's the same both ways, because I feel like we're going to end up with degree on both would be the same, so it'll just be I feel like it's going to be some
It graphically almost is hard to tell too. Yeah. I think we will be surprised as x is approaching negative infinity. We're going to do this one later, guys. You guys aren't ready for it yet. Well, it's not that you're not ready for it. You are, but I don't have time for it. I would highly recommend you guys get as much done in the homework packet over the weekend as you can, so that on Wednesday, if you guys have questions before the test, I'm available. Like, do you guys get what I'm saying there? I'm sorry? Yeah. Originally, I had it set for Wednesday, but you're not ready. So I got to figure out, I'll have to rework the calendar a little. There's a little bit of room. I might have to assign a video notes to stay on pace. For like one day of notes, like an easy day of notes where you guys do it over video.
Joe, I will, dear.